Hello everyone. In today's video we are going to discuss a problem on the voltage regulation, sending in and receiving the voltage calculations. Okay, and the problem here is as follows. At a 3-phase 11 kV bus, a load drawing 2 plus J1 MVA is connected. The radial line voltage is 11 kV. The total system resistance is 0.5 ohm per phase. We need to calculate these parameters starting from receiving end current. Second one is regulation, the sending end voltage, the short circuit capacity of the system. And here they have mentioned we need to assume the system to be a lossless system. To continue the problem, let us list out all the given parameters first. The given bus voltage is V is equal to 11 kV and the load is 2 plus J1 MVA, which means P is equal to 2 MVA and Q is equal to 1 MVA, P plus JQ. And they had given the total system resistance as 0.5 ohm per phase, which means Z is equal to 0.5 ohm per phase. Now with these given parameters, let us solve the problem. Before starting the solution, let us I just want to remind you people, we are going to solve this entire problem with respect to a per unit system so that the calculation would be much easier. Okay, let us start the problem with the base values. Let us assume or choosing the base value here as follows. The base voltage is 11 kV line to line and the base power as 1 MVA. Therefore, P per unit would be 2 MVA divided by 1 MVA is 2 per unit, and Q per unit is 1 MVA divided by 1 MVA is 1 per unit. Okay, and after getting the per unit value Q and P, the Z per unit, or Z, to calculate the base value, Z base value, ZB would be kVA, kV square divided by MVA, which means the kV square is 11 square divided by MVA is 1, which leads to 121 ohm. The base Z base is 121 ohm. Therefore, we got X is equal to 0.5 divided by 121, which leads to 0.00413 per unit. The value of X is 0.00413. Okay. And now the angle, to calculate the angle, phi is equal to tan inverse of Q by P 1 divided by 2, which is equal to 26.55 degree, which leads to cos phi is equal to 0.8994. Okay, we got the value of cos phi and X per unit value. P is 2, Q is 1 per unit, and X is 0.00413 per unit, and the value of cos phi is 0.8994. Now we need to calculate firstly the receiving end current. Let us start with the receiving end current. To calculate the receiving end current, IL per unit would be equal to P divided by V cos phi. The value of P is 2. Remember, we are solving it with respect to per unit. P per unit is 2 divided by V is 1 into cos phi is 0.8994 leads to 2.236 per unit, and the value of I base is MVA base divided by root 3 into V line to line base. The MVA base is 1 mega, 1 into 10 raised to 6 divided by root 3 into 11 kV, 11 into 10 raised to 3, which is equal to 52.486 amps. Now, therefore, the value of IL is equal to IL per unit into IB, which is equal to 2.236 into 52.486. The value of IL is equal to 117.359 amp. This is the value of IL, receiving end current. Secondly, we are going to calculate the regulation. To calculate the regulation, we need a sending end voltage and a receiving end voltage. Okay, but the sending end voltage is unknown. We need to find that to calculate the regulation. So let us calculate first the sending end voltage, then we can come back to the voltage regulation. So now we are going to identify secondly the sending end voltage. Sending end voltage equation is E square is equal to V plus X cube divided by V whole square plus XP divided by V whole square. On substituting all the parameters, we will be getting E square is equal to the value of I will rewrite the equation here so that it would be easy for the paper. The same equation, E square is equal to V plus X cube by V plus X cube by V whole square plus XP divided by V whole square. On substituting all in terms of per unit, V is 1 plus X is 0.0043 into the value of Q is 1 divided by again V is 1 whole square plus X is 0.00413 into P is 2 divided by V is 1 whole square, and E square is equal to 1.00834 per unit. Therefore, E is equal to 1.004 per unit. This is the per unit value of E, sending end voltage. The exact value of E is equal to E per unit into 11 kV, which is equal to E is 1.004 into 11 kV, 11.045 kilowatt. This is the sending end voltage. After getting the sending end voltage, we can now calculate the regulation. Percentage regulation is equal to sending end voltage, that is 11.045 minus receiving end voltage divided by receiving end voltage into 100, which is equal to 0.41%. Percentage regulation is 0.41%, which is voltage regulation is very good. And now lastly we are going to identify the question we are having. We have calculated receiving end current, the regulation and the sending end voltage. Now we need to find the short circuit capacity of the system. So lastly we are going to identify short circuit capacity. Short circuit capacity is given by V square by R, and V square is 11, the value of V is 11, it was line to line divided by root 3 line voltage whole square divided by R, the value of R was 0.5 in the given system, which is equal to 80.667 MVA per phase. Remember, here we have taken the receiving end voltage 11 kV. Okay, to get the exact short circuit capacity, for accurate short circuit capacity, it would be better if we use the sending end voltage. If we use the sending end voltage, V square by R would be 11.045 divided by root 3 whole square divided by R is 0.5, which would be 81.328 MVA per phase. This is the short circuit capacity. This is per phase. For 3 phase, the short circuit capacity would be 243.98 MVA. Okay, this is for per phase and this is for 3-phase system. This is the solution for the problem. If you people have any doubts, please do message on my comment box. And for the receiving end voltage, to calculate the receiving end voltage, we have used this equation. To know much about this equation, how we got this equation, please do click on the above link to get to the equation. Okay, please be connected. Thank you.